I want to begin by cautioning you about what I'm about to show you, because I don't want you to start seeing this everywhere. But there is something called an SnAR substitution reaction that's a much different type of concept within benzene rings. And this takes place when you have a strong deactivator that is specifically ortho or para to a really good leaving group. So things like a halogen, really that's what you've seen so far. And you can do this in a base. You take some heat and then you follow it up by some acid there, and then you can get sort of a substitution type of reaction. Well, there's a reason why. And in this case, instead of attacking with an electrophile, this is actually a nucleophile attacking. So they're going to come in here, and electrons will then shift. So it's going to go into the ring, it can come out into the nitro group. That's the reason why this can exist. And when it comes back in from the nitro group, these electrons go down and that kicks out that chlorine, and that's how you end up getting that OH right there. Okay. So moving on, I want to review a few things with organolithium reagents. So just to remind you how these are made, we start with an alkyl halide. That's the reason why you can't use an alkyl halide in the coulis, right? So these are called Gilman reagents, but we call them coulis because they're cool like that. And you can react that with lithium. So this makes an organolithium reagent, which we'll talk about more in class. And then once you do react that with copper iodide, you end up with this guy. Okay, so caution, you end up with two of these R groups. Recall, you only use one of them. So you want to make sure that this guy is inexpensive, otherwise you just lost your job for using something too elaborate. So you got to be careful with that. These can react as they are, which we'll talk about later in the semester. We've already talked about Grignard reagents, but basically these are ways to get sort of like a carbanion in situ, and that's sort of how they react. So these can actually replace a halogen, or basically a halogen. You end up with an R group right here that will work with aryl, vinyl. It works with just about everything. And a couple other reactions that I just want to expose you to is the Simmons-Smith reaction. And essentially what you end up with here is you make an intermediate with the zinc and the copper that sort of supports a carbene type of structure, so something that you see right here. So imagine a carbon with free electrons, but it's not really free electrons because you're starting to connect it to other metals around. And essentially that carbene's up here, electrons exchange with that double bond, and you end up with a CH2 right there. In a very similar way, if you have a strong base with CHCl3, you can make this type of guy that will react with a double bond to give you that. Okay, nice simple reactions today.